Every pixel on a smartphone is filtered through highly engineered sand. The transparent world around us, from windows to lenses, started as raw earth. Natural glass forms through sudden, intense heat. When lightning strikes a desert, the electricity fuses the silica into rough, hollow structures called fulgurites. We see this process again in volcanic zones. When lava cools rapidly upon hitting the air, it solidifies into large, dark blocks of obsidian. Ancient people used these natural deposits to craft sharp tools and weapons. By roughly 300 BC, humans learned to replicate this process, using campfires to melt sodium-rich sand into the first artificial glass. Those early materials were opaque and fragile. Producing the high-clarity glass used in modern technology requires a sophisticated sequence of thermal and chemical engineering. Modern manufacturing requires sand far purer than what you find on a beach. It begins in quarries, where dynamite blasts apart rock faces to reach quartz containing 99% pure silica. Massive industrial mills grind these rocks into a fine powder. From there, industrial washers scrub 220 tons of sand every hour to remove surface contaminants. Centrifugal force then separates out heavy metals that would weaken the glass. By spinning the mixture at high speeds, engineers pull the denser impurities away from the silica. A final magnetic field sweeps through the mixture to remove microscopic iron particles. If even a trace of iron remains, the glass will lose its perfect transparency, taking on a permanent green or brown tint. Achieving this level of purity ensures the final material is structurally sound and completely invisible to the eye. Silica has a high melting point, so engineers add sodium carbonate. This lowers the temperature threshold required for the sand to liquefy. However, sodium makes the glass water-soluble. Adding calcium carbonate stabilizes the structure, giving the material its permanent durability. This is also the stage where color is introduced. A small amount of cobalt oxide can dye the entire batch a deep blue. The mixture enters a gas furnace, where temperatures reach approximately 1,700 degrees Celsius. This environment is hotter than liquid volcanic lava. To manage this heat, workers must wear specialized Kevlar gloves and fireproof suits. They monitor the mixture for 24 hours until the rock completely transforms into a glowing liquid. This day-long melt rewrites the molecular structure of the stone, turning opaque powder into liquid fire. To turn this liquid into a usable product, engineers use CAD software to design precise molds. These designs guide the robotic double-blow production lines. Drops of liquid glass fall into the molds and are blasted with high-pressure air. The glass takes its final shape in a matter of seconds. Modern automation has replaced the labor-intensive methods of the past, where teams of workers manually operated mechanical levers to shape every individual piece. However, the new glass is still extremely hot. If it cools too quickly in room temperature air, internal stresses will cause it to shatter instantly. The glass travels through a long annealing tunnel, which slowly reduces the temperature. This gradual cooling process is what gives the material its final strength. Once cooled, the glass faces an unforgiving inspection. High-speed cameras and optical sensors scan each piece for microscopic bubbles or cracks. Any piece with even a minor blemish is immediately rejected. Only the flawless units continue to the robotic packaging section. Rejected pieces and old bottles are never wasted. They are collected, crushed, and returned to the furnace, reducing the energy required for the next batch. Consider this cycle the next time you use a glass or touch your smartphone. The invisible surface in your hand is a refined piece of the Earth's crust that has survived high explosives, chemical restructuring, and temperatures hotter than a volcano. It is a masterpiece of engineering hiding in plain sight.